Every single day, in kitchens all over the world, millions of people open their refrigerators, pull out last night's leftovers, and do something so routine, so automatic that almost nobody stops to think about it. They reheat their food. It's a habit baked into modern life. A rice cooker running twice a week, a microwave humming after a long shift at work, a pan sizzling with yesterday's dinner, because cooking from scratch every single night simply isn't realistic for most people. And why would anyone question it? Reheating food feels safe. It feels smart. It feels like the responsible thing to do, saving money, reducing waste, making sure nothing good goes in the trash. But what if the very act of reheating certain foods, done the wrong way or too many times, quietly changes their chemistry in ways that could matter for your long-term health? What if the difference between a harmless meal and a genuinely risky one isn't the food itself, but the heat, the timing, and the number of times it's been warmed back up? This is not a story about panic. It's not about telling you to throw away your leftovers or live in fear of your own microwave. It's about understanding something that food scientists, toxicologists, and nutrition researchers have been quietly studying for years. The way heat interacts with certain molecules in food, and how repeated heating cycles can, under the wrong conditions, encourage the formation of compounds that have been linked, in various studies, to increased cancer risk. The operative words here are under the wrong conditions and linked to, because nothing in this script is about absolute certainties or guaranteed outcomes. Nutrition science rarely works that way. Instead, it works in probabilities, patterns, and mechanisms. The slow accumulation of evidence that tells us, this matters, this is worth paying attention to, this is worth changing a habit over. So let's start with the basic chemistry, because understanding why is what makes this genuinely useful information instead of just another scary headline. Heat is a powerful force. It's what makes raw ingredients into cooked meals in the first place. It breaks down proteins, gelatinizes starches, releases aromas, and transforms textures. That's a good thing. It's why cooking exists. But heat is not a neutral, one-directional process. Apply it once and you get browning, flavor development, and safe, edible food. Apply it again, and again, and again, and you start pushing certain molecules past their stable state into new configurations. Fats can oxidize further, proteins can rearrange into different structures, and in some foods, naturally occurring compounds like nitrates can be converted, step by step into nitrites, and eventually into a family of substances called nitrosamines, some of which are classified as probable or possible human carcinogens by health agencies. None of this happens with every food. It's not a universal rule that reheating equals cancer. It's specific. Certain foods, certain conditions, certain patterns of behavior that over months and years might tip the odds in an unfavorable direction. And that's really the heart of what this 4-part series is about. We're not talking about one bad meal ruining your health. Cancer risk, as researchers understand it today, is rarely about a single exposure. It's about cumulative patterns, repeated behaviors, small choices stacked on top of each other for years or decades. One reheated portion of a certain vegetable is not going to hurt you. But if that same habit, reheating the same food the same way multiple times a week for years, becomes part of your normal routine, the science suggests it's worth a second look. This is why nutrition experts increasingly talk not in terms of good foods and bad foods, but in terms of good patterns and risky patterns. Reheating is one of those overlooked variables that quietly slots into the pattern category. Invisible, routine, and almost never discussed at the dinner table. Over the course of this series, we're going to walk through 4 specific foods where the science on reheating deserves real attention. Not urban legend, not internet myth, but findings drawn from actual research into food chemistry and toxicology. Some of these might surprise you because they're foods considered healthy. In their original form, vegetables praised for their nutrients, oils marketed as heart-friendly, proteins recommended by dietitians. That's part of what makes this topic so important. It's not about junk food villains you already suspect. It's about ordinary staples sitting in your fridge right now, foods you might reheat 2 or 3 times a week without a second thought. Foods that, when heated multiple times or at high temperatures, can undergo chemical changes that shift them from beneficial to potentially concerning. We'll break down exactly what happens at a molecular level with each of these 4 foods. We'll explain the specific compounds involved, where they come from, how they form, and what current research says about their connection to cancer risk. We'll also cover something equally important, what you can actually do about it. Because the goal here isn't to scare you away from your kitchen. It's to arm you with practical, evidence-based habits that let you keep enjoying your favorite meals while minimizing unnecessary risk. Small adjustments, how you store food, how many times you reheat it, what temperature you use, how long you let it sit before refrigerating, can make a meaningful difference without requiring you to overhaul your entire diet. Let's start with the food nobody expects, spinach. Yes, spinach. The same leafy green that dietitians praise for its iron, its folate, its antioxidants. The same vegetable parents guilt trip their kids into eating because it's good for you. Spinach has spent decades as a symbol of healthy eating, thanks in no small part to a certain cartoon sailor and a century of nutritional advice. So it might come as a genuine shock to learn that spinach sits near the top of the list when food scientists talk about reheating risks. Not because spinach is secretly unhealthy, it isn't, but because of a specific chemical property it shares with several other vegetables. It's naturally high in nitrates. Nitrates themselves are not dangerous. They occur naturally in soil, they're absorbed by plants as part of normal growth, and they show up in high concentrations in leafy greens, beets, celery, and a handful of other vegetables considered nutritional powerhouses. In their original form, nitrates are harmless, and in fact some research even suggests dietary nitrates from vegetables can support healthy blood flow and cardiovascular function. The problem isn't the nitrate itself, it's what can happen to that nitrate after it's cooked, cooled, stored, and then reheated, particularly if that reheating happens more than once or at improper temperatures. Here's the mechanism, broken down simply. When nitrate-rich food is cooked and then left at room temperature, say, sitting out on the counter while dinner winds down, or stored in a container that isn't cooled quickly enough, naturally occurring bacteria can begin converting those nitrates into nitrites. This is a normal chemical process. It happens gradually and depends heavily on time, temperature, and exposure to air. Nitrites, on their own, still aren't necessarily dangerous in food. But when nitrite-containing food is then reheated, especially at high temperatures, there's potential for those nitrites to convert further into compounds called nitrosamines. Certain nitrosamines have been studied extensively by cancer researchers, and some are classified by international health bodies as probable or possible human carcinogens based on animal studies and, in some cases, associations found in human population data. This is the exact chain of events that food safety researchers in several countries have flagged when it comes to reheating spinach and similar vegetables. Not a single event, but a chain nitrate to nitrite to nitrosamine accelerated by improper storage and repeated reheating. Now it's worth pausing here to add nuance, because headlines love to strip nuance away. The risk with spinach isn't about eating it once, warming it up once, and moving on with your life. Millions of people do exactly that every single day with no measurable consequence. The concern that food safety experts actually raise is much more specific. It's about spinach, or similar high nitrate vegetables, being cooked, left out at room temperature for extended periods, refrigerated late, and then reheated multiple times, sometimes across several days. It's the combination of factors, slow cooling, extended storage, and repeated reheating, that creates the conditions for nitrite and nitrosamine formation to actually become meaningful. A single reheated portion, handled properly and eaten within a reasonable window, is not the same chemical situation as spinach that's been sitting in the fridge for 4 days and zapped in the microwave for the 3rd time. This is actually why food safety agencies in countries like France and Germany have issued specific guidance for years around nitrate-rich vegetables, recommending that spinach, and vegetables like it, be cooled quickly after cooking, refrigerated promptly, consumed within a day or 2, and ideally not reheated more than once. Some guidance even suggests avoiding giving reheated spinach to infants and young children, whose bodies process nitrites differently and less efficiently than adult bodies do. A detail that underscores just how specific and condition-dependent this risk actually is, rather than being a blanket warning against a nutritious food. So, what does this actually mean for your kitchen? It means the vegetable itself isn't the enemy. The handling is. If you're someone who batch cooks a big pot of spinach curry or a spinach and egg scramble on Sunday and portions it out for the week, the key isn't to stop eating spinach. It's to change how you store and reheat it. Cool it quickly rather than letting it sit at room temperature for hours. Refrigerate it within 2 hours of cooking. Try to eat it within a day, maybe 2 at most. And where possible, reheat only the portion you're going to eat, rather than reheating the entire batch repeatedly over several days, which multiplies the number of heat cycles the nitrates in that spinach are exposed to. There's something almost poetic about this particular fact, honestly, that the food most associated with strength and health in pop culture is also the food most likely to catch people off guard in a conversation about cancer risk. But that's exactly the point of starting this series here. This isn't about vilifying vegetables or telling you to fear your salad. It's about revealing how a chemical process most people have never heard of, nitrate to nitrite to nitrosamine conversion, can quietly turn a storage and reheating habit into something worth reconsidering. Spinach isn't dangerous. Spinach handled carelessly, cooled slowly, and reheated repeatedly over days might carry a small but real elevated risk that's easy to eliminate with just a few small changes in the kitchen. Now we come to the food sitting in almost every household on the planet in some form or another: rice. Rice is about as neutral as food gets in the public imagination. It's bland, it's simple, it's the base of 1,000 different cuisines from every corner of the globe, and it seems almost impossible that something so plain could carry any hidden risk at all. But rice occupies a strange and important place in this conversation, because the danger with rice isn't really about cancer in the same direct chemical sense we just discussed with spinach. It's about something subtler, and in some ways more immediate, that sets up the conditions for long-term risk through a completely different mechanism. Bacteria, toxins, and the way our bodies respond to repeated low-grade exposure over time. Here's what most people don't know about raw rice. It can carry spores of a bacterium called Bacillus cereus. These spores are incredibly hardy. They survive the cooking process itself, because cooking temperatures, while enough to kill most bacteria, aren't always enough to destroy these particular spores. Under normal circumstances, this isn't a problem. The spores are dormant, inactive, harmless as long as the rice is handled correctly after cooking. But if cooked rice is left sitting out at room temperature, on the counter, in a rice cooker left on warm, for hours, or on the stove waiting to be portioned out, those dormant spores can begin to germinate. As they multiply, some strains of Bacillus cereus produce toxins, and repeated exposure to bacterial toxins, along with the byproducts of bacterial overgrowth in food, has become an area of increasing interest for researchers studying long-term gut health and its relationship to inflammation. And chronic, low-grade inflammation is one of the most well-established contributing factors in the development of several types of cancer over time. This is different from the spinach story in an important way. With spinach, we were talking about a direct chemical transformation, nitrate to nitrite to nitrosamine, a compound with a fairly well-established, if still being refined, link to cancer risk. With rice, the concern operates on a different level. It's not that reheated rice contains a carcinogen in the same direct sense. It's that improperly stored and repeatedly reheated rice creates a breeding ground for bacterial toxins, and the body's repeated immune response to those toxins, inflammation, oxidative stress, cellular damage, and repair cycles playing out over and over, is exactly the kind of chronic biological wear and tear that researchers now understand can, over years, contribute to the environment in which cancer is more likely to develop. It's an indirect pathway, but it's one nutrition scientists take seriously, because chronic inflammation isn't a minor side detail in cancer research anymore. It's considered one of the central mechanisms connecting lifestyle and diet to long-term disease risk. There's also a second layer to the rice story that's worth understanding: starch retrogradation. When rice is cooked, its starches gelatinize. They absorb water and become soft and digestible. But when that rice cools down and is stored, especially in the refrigerator, the starch molecules begin to realign into a different structure, a process called retrogradation. When that rice is then reheated, especially at high heat or for extended periods, and especially if this cooling and reheating cycle happens multiple times, it can create structural changes in the starch and, in some studies, contribute to the formation of compounds during the browning and drying process at the rice's surface. Similar in category, if not always in scale, to the kinds of heat-driven compound formations researchers have flagged in other reheated starchy foods. This isn't as well established or as heavily studied as the Bacillus cereus concern, but it's part of a growing body of research suggesting that just reheat it, and it's fine, isn't quite as universally true as most of us assume. What makes rice particularly worth discussing in this series is how common the risky pattern actually is. Think about how many people cook a large pot of rice, leave it out on the counter while everyone eats dinner and chats, then put the leftovers in the fridge an hour or two later. Or don't refrigerate it until after they've gone to bed. Think about how many people reheat that same batch of rice 2, 3, 4 times over the course of a week in the microwave, straight from a container that's been sitting in the fridge without being properly sealed. This isn't a rare mistake. It's close to the default behavior in millions of households, which is exactly why food safety agencies in the UK and elsewhere have issued specific public guidance about rice, warning that it should be cooled within 1 hour of cooking, stored in the refrigerator, and ideally eaten within 24 hours, reheated only once, and reheated thoroughly until steaming hot all the way through. The good news here is that the fix is almost entirely about timing and habit, not about giving up rice. Cook only what you'll realistically eat within a day or two. Cool it quickly. Spreading it out on a shallow tray speeds up cooling significantly compared to leaving a deep pot to cool slowly. Refrigerate it promptly rather than letting it sit on the counter for hours. And when you do reheat it, do it once, thoroughly, and make sure it's heated evenly all the way through rather than leaving cold spots where bacteria could still be active. These aren't complicated changes. They're small shifts in kitchen routine that dramatically reduce the actual risk, while letting you keep rice exactly where it belongs. As a staple, not a suspect, we end this series with a category of food that ties everything together: cooking oils, and by extension, any food reheated in oil that's already been used once or twice before. This includes fried foods, sautéed leftovers, and that pan of stir-fry sitting in your fridge that still has a slick of oil clinging to it from last night. Unlike spinach and its nitrates, unlike rice and its bacterial spores, the concern here is about lipid oxidation. What happens to fat molecules when they're repeatedly exposed to high heat, especially heat applied more than once to the same batch of oil? Here's the chemistry in plain terms. Cooking oils are made up of fatty acid chains, and those chains are relatively stable the first time they're heated to normal cooking temperatures. But every time oil is heated, cooled, and reheated, some of those fatty acids break down and reform into new compounds, including aldehydes and in some cases, further along the degradation pathway, compounds researchers have studied for their potential role in cellular damage. Repeated heating also accelerates oxidation, and heavily oxidized fats have been a genuine area of interest in cancer research for years now, particularly around chronic, repeated exposure rather than a single meal. The higher the heat and the more times the same oil is reused, the more these breakdown products accumulate. Deep-fried food reheated in a pan with the same oil still clinging to it, or food that's been fried, cooled, refrigerated, and then reheated in a way that essentially recooks the oil a second or third time is the exact pattern that raises concern. This is why the practical fixes for this category look a little different from the other three. It's less about storage timing and more about oil habits altogether. Avoid reusing the same oil for multiple frying sessions, especially at high heat. When reheating fried or oily leftovers, use gentler methods. An oven at moderate temperature or a covered pan on low heat, rather than blasting them in a hot skillet or deep frying them again. And where you can, blot excess oil before storing leftovers, since oil sitting on the surface of food in the fridge continues to slowly oxidize even before it's reheated at all. Bringing all 4 parts together, a clear pattern emerges. Spinach and nitrate-rich vegetables need fast cooling and limited reheats to avoid nitrosamine formation. Rice needs quick refrigeration and a single, thorough reheat to avoid bacterial toxins and inflammation driving byproducts. Oils and fried foods need limits on reuse and gentler reheating to avoid oxidative breakdown compounds. None of these risks come from eating these foods. They come from specific patterns of handling, slow cooling, extended storage, and repeated high heat reheating stacked together over months and years. Adjust those three variables, and the actual risk drops dramatically, no matter which of these 4 foods you're serving tonight. That's the real takeaway of this series. Not fear, but attention. Small, deliberate changes to storage and reheating habits applied consistently are enough to close the gap between an ordinary weekly routine and one that quietly works against you over time.